Hi guys, welcome to another video of physics. This is the first problem about the vertical throw upwards problem. Okay, so let's do it. It says a person throws a stone vertically upwards at 25 meters per second. Find. This is the only data that they give us. Find how much time does it take to reach the maximum height. What is the maximum height reached, and what is the velocity of the stone when returns to the origin? Okay, so if you remember in the previous video, well, I explained all the concepts about vertical throw, in this case upwards, going upwards. So I'm gonna change the screen. So I have here the drawing. Okay, so what I'm going to do, I'm going to fill this drawing with the information. So if you remember in the previous video, okay, this is vertical throw. I'm gonna erase this because uh, it's going to represent an obstacle to me in order to complete the drawing. Okay, so if you remember, I told you that this will be the segment number 1, and this is the segment number 2, because there is a line that divides the motion, the vertical throw, in two equal segments. This is the one that goes up, and this is the one that goes down. Okay, so let's fill this drawing with the information. So this is the beginning of the motion. So to me, this will be the initial position of the segment number 1. And I told you that it was going to be 0 meters most of the times. The initial velocity of the segment number 1, in this case, they give us that information, that is 25 meters per second. And remember that we're going to have the acceleration, the value of the gravity, that is minus 9.8 meters per second squared. So that means that the object will be decreasing the velocity by 9 meters per second each second. So at this point over here, this will be the point where the velocity of the object is 0 meters per second. So, and then we'll continue, we'll start going down. So this is the final position of the segment of number 1. Okay, that is the maximum height. Okay, and at that point, the final velocity of the segment number 1 is 0 meters per second, always. So that's the segment number 1. Also, we got the segment number 2, and I'm gonna write the data again, but for the segment number 2. So in the segment number 2, the motion start here at the maximum point. So that would be the initial position of the segment number 2, and that is the maximum height. Also, remember, this is the start, and I guess I told you in the previous video that the segment number 2 is going to be treated as free fall. Okay, so I'm gonna write the initial velocity of the segment number 2 is 0 meters per second, because in free fall the initial velocity is always 0. And remember that the velocity at the highest point is 0 meters per second. Okay, so here is the final point. So, we got the acceleration, that is gravity, that is minus 9.8 meters per second square. So this acceleration will be the one that will be responsible of decreasing the velocity 9.8 meters per second each second, due to the value that the acceleration is in 0. So the velocity will become negative. Okay, so here, this is the end of the motion. So this will be the final position of the segment number 2, and that will be 0 meters. Remember that they are kind of inverted. This is the initial and this is the final. And also we have the final velocity of the segment number 2, And I told you that this velocity, the initial velocity, will be the same as the final velocity, but with opposite sign. So with that in mind, well, I guess I just answered the third question. What is the velocity of the stone when it returns to the origin? So it will be minus 25 meters per second. That's kind of a law, assuming that we don't have friction of the air or temperature or pressure and so on and so on. Okay, so also remember that we got the time 2, the time that takes this object to reach the origin, and also I got the time 2, time 1, sorry, the time that takes the object to reach the maximum height. And remember I told you that time 1 equals time 2. Okay, so that is the drawing. Let's write the data. Well, I already got the data here in the drawing, so I'm not gonna write it because that would be more work to do. So I'm just going to write the equation. So acceleration equals final velocity minus initial velocity over time, and final position equals initial position plus initial velocity that multiplies the time plus acceleration times square over 2. Okay, so in order to solve this problem, remember we have two segments here, and it's up to you which segment you want to use. You can use the segment number 1 or the segment number 2 as you wish, depending, well, it doesn't matter which segment you chose, the answer will be the same as long as you make the right procedures. I mean, your procedures to perform are correct. So just be careful when you make those procedures. Okay, so in this case, I'm going to choose the segment number 1. Okay. Why? Because I want. Okay. As I said, I'm gonna say it again. You can choose any segment that you want. So I'm gonna choose the segment number 1, and I'm gonna say I have acceleration, I have the final velocity, I have the initial velocity, and I don't have time. So I'm going to find the time, and I can cross the final velocity because the final velocity of the segment 1 is 0. So I can cancel this one. So acceleration equals minus or negative initial velocity of the segment 1 over time 1. Okay, so I'm going to find time 1. Time 1 equals minus initial velocity of the segment 1 over acceleration. So this will be negative 25 meters per second over negative 9.8 meters per second square. I'm gonna cancel meters per second with boom, boom. And the time must be positive. Remember, time must be positive. So far, we haven't found negative time. I hope we can find them later. Okay, so it will be negative 25 over negative 9.8. Boom. So this answer has infinite values. So I'm gonna save this value in the memory A of the calculator. This answer got saved in A. Okay, so I'm gonna write that answer 2.55 10 seconds. I'm gonna circle with red because that is the answer that they want me to find, and this is saved in the A memory of the calculator. Okay, so now, well, I answered the letter A. Now let's find the letter B. What is the maximum height reached? Let's suppose that I continue working with the segment number 1. Okay, so in the segment number 1, well, I have final position. No, I don't have it. That is the maximum height reach. Okay, initial position, I have it. The initial velocity, the time, I just found it. The acceleration and the time. Okay, from this equation, the only thing that I can cancel is the initial position of the segment number one. If you see, is 0. So I'm gonna cancel this one, and I'm gonna write the equation again. Final position of the segment number 1 equals initial velocity of the segment 1 that multiplies the time of the segment 1 plus the acceleration that multiplies the time of the segment 1 raised to the square over 2. Okay, so this is going to be 25 meters per second that multiplies 2.55 seconds plus minus 9.8 meters per second square that multiplies the time, that is going to be 2.55 seconds raised to the square over 2. Okay, so let's do it in the calculator. It's a long formula. Okay, so parentheses 25 times 2 times the value of a plus fraction negative 9.8 times the value of a raised to the square over 2. So let's see. Boom. Yes, that's the maximum height reached by the object, by the stone. So final position of the segment number 1 is 31.88 77 meters. Yes, because seconds, boom, cancel with second, and second square got canceled with second square. Okay, so that's the answer. But before we finish the problem, what would happen? What would have happened if I choose the segment number 2 for the in order to find the letter B, what it was the maximum height reach? So let's say that I choose the second segment, and I'm gonna write it here, okay? And I write the equation again. Final position equals initial position plus initial velocity that multiplies the time plus acceleration times square over 2. I guess by this moment you already memorized this equation because I talked about these two equations over and over and over and over again. Okay, so final position, I have it. Yes, this one I don't. This, yes, 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 yes. Okay, I'm gonna cancel everything that is 0. So this one is 0 and the initial velocity is 0. So initial velocity that multiplies something is going to be 0. Boom. So I cancel that. So 0 equals the initial position of the segment 2 plus the acceleration times the time of the segment 2 raised to the square over 2. Okay, so the initial position of the segment 2 equals minus or negative acceleration that multiplies the time 2 raised to the square over 2. So if you see, well, I get an equation that is shorter than this one, and that's an advantage. I believe that's an advantage because the longer the equation, more problems you might get by solving that equation, because the probability that you make a mistake, those probabilities increase. Okay, so in this case, the only thing that I need to do, and remember, this is a formula of free fall because the segment number 2 is free fall. So you can use the formulas that we already found in free fall if you want. Okay, that's just a recommendation if you want. Okay, so minus 9.8 meters per second square. Sorry, is negative. Remember this negative over here. This negative over here. Okay, this negative and also the negative of the acceleration by itself times 2.5 55 seconds raised to the square over 2. So let's do in the calculator to see the answer, initial position of the segment number 2. Fraction, negative, parenthesis, negative 9.8 times the value that I got in A raised to the square over 2. And if you see, we got the same answer. Turn down for what? 31.8877 seconds. I told you, it doesn't matter which segment you choose in order to solve the problems as long as you make the correct procedures. Okay, in this case I chose well, I made the first letters questions with the segment number 1, and then I switched to the segment number 2 just to show you that okay, there is a different equation. This is the equation for the segment 1 and this is the equation for the segment 2, but at the end we got the same answer. Okay, so this was the first problem about vertical throw upwards, and I hope guys I can see you in the next video. Bye bye.